Hello, fifth grade. We're going to go ahead and get started on our Science 7.6. Now, this is basically all the layers of the atmosphere. Now, the unique thing about our atmosphere is we look up in the sky and we see blue. That's what we see. We see our clouds, we see the birds, we see sunshine, we see airplanes flying around in the sky. But what we don't realize is there are many different layers going all the way up into outer space protecting our Earth. Now, God created our Earth rotating in this atmosphere, right, around the sun, or rotating in the universe, in space, rotating around the sun. But what he did also was protect it with this big layer around it, and that is the layers of our atmosphere. Okay, now we know that there's air going up, right? We see air, and as we go up, we know that air gets thinner as it goes up. Well, it gets really thin when it's really, really, really high out in our atmosphere. So let's go ahead and go through our layers. Now, our first layer, obviously, we have our Earth down here, so I'm showing you how this all works, okay? And our first layer is the troposphere. Now, the troposphere is the closest to the Earth, okay? Oh, I just realized that should say Earth. That's funny. Okay, I'm going too fast. You know me. Okay, so closest to the Earth. Okay, now this layer is the layer that has most of the water vapor in it. Now what that means is that's where all of our weather is formed, okay? Because the air is thicker down here, and because it forms clouds in the troposphere. And this is basically where our planes fly. So most of what we do on Earth is here in the troposphere, okay? Now, above that part, there's like a kind of like a layer where then we hit and we go to a certain point. And that's anywhere from about 6 miles to 12 miles above, okay? And so then we hit our stratosphere. Okay, now a stratosphere is also a layer that helps protect the Earth from ultraviolet rays. Okay, it also, in this layer, some aircraft fly kind of like jets and things, and they fly but in the lower regions of the stratosphere because they want to avoid turbulence from weather. Now you're asking, how do they avoid the turbulence from weather there versus here? Well, because this is where no clouds are formed. Okay, so no clouds are formed in the stratosphere, meaning no weather, so no turbulence. Okay, now this is also the location of the invisible shield called the ozone layer. Okay, that's what helps protect us from the ultraviolet rays. Okay, this is the stratosphere. Now our next layer up above that is the mesosphere. Okay, and that is a cold layer of air, okay? So we know that as we're going up, if you were to ever look outside your airplane, you would see sometimes moisture on the airplane, right? Sometimes cold, sometimes froth. That's because as we go up, not only are we in the clouds, but we're also getting, the air is thinning out as we go up and it's getting colder, okay? Then in the mesosphere, it also helps protect us from objects in outer space like meteoroids, okay? And meteoroids is basically space junk flying around, okay? And sometimes we call them meteoroids, okay? And or a meteor. When we call it a meteor, it's because that is actually when the space junk, okay, burned up as it entered into the mesosphere because of the friction as it entered in from the thermosphere into the mesosphere. So that space junk is coming in, and as it comes through this layer, it actually causes friction. And think back to friction, we're slowing it down, okay? So as it's coming in, it actually is hitting that layer, and that layer is slowing down the object so it doesn't come down and hit us. Now, yes, sometimes things do come all the way down. Maybe it's just coming at such high speeds that friction doesn't even stop it. But for the most part, this is where it slows down if it's getting into the mesosphere. Okay, so once that friction happens, it actually burns up the object, and that's where we see like a shooting star, we call it, or a meteor. Okay, now above the mesosphere is the thermosphere. Now the thermosphere, the air is very scarce there, okay? So very, very, very thin, okay? This is also called the ionosphere, okay? And that is because of the air being so scarce, the atoms are not bouncing around and the molecules and everything is so spread apart and everything, so they also can call it the ionosphere. Okay, now this is where air glow happens. Okay, and air glow is like a phenomenon that you can witness sometimes on a moonless night. It's like a glow in the air, and that is it. It's sometimes in the lower regions of the thermosphere. Okay, and this is when the atoms and the subatomic particles, and they all whirl around in the center, or the electrons whirl around in the center, and then you have the solar rays that enters the thermosphere, and they strip the electrons from the atoms, and that's called the ions, and that's where we get ionosphere. Okay, so there's a lot of atom molecules and electron things being pulled apart and stuff at that time, and that's basically where you're getting them stripping away, and that's where you end up getting that glow during that time. Okay, so now the interesting thing about the thermosphere is right above the thermosphere is the topmost layer of the atmosphere, which is the exosphere, and this one is where the air is even more scarce. Air is even more scarce, okay? C. Okay, and what that means is that up there, where did it say it? It was saying that it is the almost top layer of our protective field, but this is where like the air molecules could go like miles without hitting another air molecule. Okay, now we know there's like a whole bunch of air molecules down here because that's how we're breathing in. So there's like barely any. It's like barely any air up there. Okay, so now, oh, I forgot to tell you about how in the thermosphere, remember how I talked about like friction and the space junk coming in? Okay, well, this is the most dangerous part about our space shuttles coming back into our atmosphere, because they have to hit and come in at a certain rate of speed. That way that the friction isn't so strong, like we talked about in this part. Okay, so once it's coming in here and it's coming in and it's coming from this one into this one, that it's not so strong that when it hits into from the thermosphere into the mesosphere, it's coming in, right? And as it comes in, it has to like slow down. The space shuttle, okay, has to slow down, because if it hits that friction, it'll burn up. So there's like big protective layers that like go over the space shuttle so that it doesn't burn up when it's coming back into our atmosphere. Pretty cool, huh? Okay, now the exosphere, remember, this is the topmost layer, but it's actually not the last layer. Now, it kind of is, but it really isn't, because if you remember learning about the sun and how the sun has a magnetic field, we actually have that magnetic field that is above the exosphere, okay? Now there is where that magnetic field, it takes space junk coming into that magnetic field. If it doesn't, it tries to get it away from before it comes into these other parts of the atmosphere, okay? So the magnetic field actually sends space junk to what we have magnetic poles, which are located at the North Pole and the South Pole, okay, of our Earth. And so those magnetic poles pull everything over as a magnetic field. And so if there's space junk here, and then, or like space junk here and space junk here, and the magnetic field throws it up to here, once they hit each other, and they kind of like burn up as well and like crash. And that is where we get our aurora, which is the display of lights or the glow in the northern hemisphere up by the North Pole. There's some southern hemisphere down by the South Pole, and that's called the aurora borealis, or the aurora australis, and that's like the northern lights. So that's where like there's that big glow in the sky. That's because the magnetic field is working to take space junk and send it to those magnetic fields. Okay, and that is the topmost layer, very, very topmost layer of our atmosphere, because it's our magnetic field that's protecting us. And it's just so neat how, think about all of this. I mean, God didn't just stop at one layer. Okay, he made sure there was this layer and this layer and this layer and this layer, and then the magnetic field that's trying to throw things around to protect our earth, and it's trying to make sure everything goes around us and it doesn't come and hit us. And then he's got this layer that's protecting and this layer. I mean, it's just so amazing when you really think about God's creation and how he thought of every little detail just so that we could sustain life on earth. I mean, that's magnificent if we really think about it. So next time you look up in the sky and you see your moon, you see the sun, you see the stars, you see the air, you see the clouds, I mean, really think about how God's design just put it all together to protect us. Every part of it is there for our benefit, to protect us, for us to see his magnificentness and how vastly great he really is. I mean, it's just a wonderful thing. And I think that, I mean, I think I'll be in awe when I go to heaven one day and I just go, I can't even believe you did it all. I mean, when we really think about all the vastness of what he did, it really was amazing. So here are our layers. We've got troposphere, stratosphere, mesosphere, thermosphere, exosphere, and our magnetic field is at the top. I didn't want to leave that one out because that is also very important to know about. So I hope that you guys enjoyed learning about this. I do believe you have a worksheet for this, but go ahead and make these notes. This is good notes to know on how each of the layers of the atmosphere work. And I'm going to step to the side so you guys can press pause.